Okay, so we're going to talk about bonds now. And a bond is an interest-bearing certificate of public or private indebtedness. So when you buy a bond, you're essentially making a loan to the issuer of that bond. And the issuer could be some kind of government entity like a municipality or the federal government. That would be a public type bond. Or it could be a corporation, so a corporate bond then you would be making a loan to a corporation. So a bond specifies a contract that promises to make a schedule of payments from the issuer to the bondholder, and the price of that bond is how much the buyer of that bond is willing to pay for that series of payments. So in general, a bond is going to specify a face amount. So in this example that I'm going to work through, the face amount of my bond is going to be $10,000. And there's going to be a bond interest rate, or sometimes called the coupon rate. So that's going to tell me how much I'm going to get every 6 months. And so those amounts, those coupons, are always as a percentage of the face amount, and that percentage is the coupon rate. So for my example, I'm going to set the coupon rate at 10%. That's an annual rate when they give you the coupon rate. So and usually the coupons are payable every 6 months. That'll be specified, but that's what we'll assume unless told otherwise. So in this case, since the coupon rate is given to be 10%, I'm really going to get half of that, or 5%, every 6 months. So 5% of 10,000 would be the amount that I get paid every 6 months. That's my coupon. So I've computed that over here. Coupon rate divided by 2 times the face amount gives me the amount of the coupon. So every 6 months, I'm going to get $500. So I'll put that over here, coupon, and all the way down. It's a 4-year bond, so that means that there's 8 half years. So my timeline goes from 0 to 8, and I'm going to get a coupon at the end of each 6-month period until the last one, but the last one, so the time of the last coupon is called the maturity date. And on that day, I get both that last coupon plus what's called the redemption amount. Okay. So the redemption amount is often, but not always, the same as the face amount. So that'll be specified in the contract. And so in this case, we'll assume it's equal to the face amount, so I get $10,500 on the maturity date. Okay. So if I pay $10,000 for this bond, that would mean I'm lending $10,000 to the issuer of that bond. So if you think in terms of how we compute the outstanding loan amount for a loan, I would compute that by taking the outstanding loan amount at time 0, multiplying by 1 plus I, where I is the yield rate, right? The rate that I want to, the interest I want to make on this investment. Now that it also will be given as an annual rate, so I need to divide that by 2 to make it a 6-month rate. And then subtract the payment, and that would give me the outstanding loan amount at time 1, 6 months from now. In this case, because I made the yield rate equal to the coupon rate, those coupons are exactly paying the interest that would be due on this loan, but no principal, and therefore the outstanding loan amount stays at $10,000. So if I copy that down, at time 8, when this bond matures, I get that last interest payment, but I also get the redemption amount, which is the same as the face amount, which in this case is the same as the price or the loan amount, and therefore the whole loan gets paid back, and I end up with 0 for my outstanding loan amount. For a bond, I call that the book value. It's really how much I'm willing to pay for this bond at any point in time, and it will correspond to the present value of any future payments. Okay, now just like with a loan, I can break up the payment into interest and principal. I'm going to do that here as well. Exactly the same as before. So the interest would be equal to the yield rate divided by 2 times the outstanding loan amount at time 0 would give me the interest for that first payment, and the principal would be the difference between the payment and the interest. Now for a loan, I would make it the payment minus the interest. For bonds, I'm going to make it the absolute value, so that if it's negative, I'm still going to think of it as a positive quantity. So I'm going to take the payment minus the interest. In this case, it's 0 anyways, because there is no principal being paid back. Let's copy that down. And for the last one, I actually don't want to count the principal being paid back for that loan. So I'm going to adjust this formula and take out the redemption amount so that I get 0 there as well. And so that's what the table would look like for this bond. Okay. Now, I made the coupon rate and the yield rate the same. That usually won't be the case. So suppose the coupon rate for this bond was only 8%. Okay? So that it's only going to pay me $400 every 6 months. So that's less than what would even cover the interest. So that's why the book value or the outstanding loan amount increases, because not only am I not paying any principal back, I'm actually accumulating interest that I haven't paid. So I really wouldn't pay $10,000 for this bond that's only going to give me $400 every 6 months, not even covering the interest. What would I pay for this bond if I want to earn a yield rate of 10%? Well, whatever price would result in a 0 outstanding loan amount at the time of maturity. So I'm going to do a goal seek, make that 0 by changing the price of the bond. And now I see that I would actually be willing to pay $9,353.68 for this bond. So less than the $10,000, because these payments are less than the interest that would be due me on a $10,000 loan. This bond is set to sell at a discount because it sells at a price that's less than the redemption amount. Okay? And the difference between the price and the redemption amount is the amount of discount. In this case, it's $646.32. So that's going to always be the sum of this column. And I call this column, instead of calling it the principal, I call it the accumulation of discount. Okay. All right. The other possibility is that the coupon rate is higher than the yield rate. So let's make it, say, 12%. In that case, those payments are going to cover interest plus some of the principal. And so I'm going to be willing to pay more than $10,000 for this bond, which is giving me much more than the interest each time. So again, I can do a goal seek right here, make that 0 by changing the price, And so this bond would sell at a price of $10,646.32. That's how much I'm willing to pay for this bond in return for these payments. The difference between this bond would be set to sell at a premium because it sells at a price that's higher than the redemption amount. And the difference between the price and the redemption amount is called the premium. And this column again will always add up to that amount, that premium. So that's how bonds work.